Today, I would like to talk about the concept of equilibrium. Now, equilibrium, if you look at the word, it kind of reminds you of the word equals, and that's because it is actually derived from that word. So, equilibrium in physics means that when you have a bunch of forces acting on a body, the resultant force, Fr, is equal to 0. That's the main definition. In other words, because there is no external net force acting on the body, your acceleration is also 0. You cannot have any kind of acceleration when you have equilibrium. Now there's two types of equilibrium. There is static equilibrium and this happens when the object is not moving. So that's the easiest one to understand. We can see that when something is not moving, there are no forces causing it to move or to deform. There is no acceleration happening. It's stable, unmoving. It's in equilibrium. Then the second one is dynamic equilibrium. Now, this one means that it is moving, but it has a constant velocity. When you have constant velocity, that means that you do not have any acceleration, and because forces are based on the fact of acceleration and mass, if there's no acceleration, you have no external resultant force. So this one, dynamic equilibrium, is a little bit harder to understand, but you have to remember that there are two types, one that is not moving and one that is moving at a constant velocity. Now, the formula for equilibrium is very simple. You're going to add up all the forces, so whether it's force 1, force 2, force 3, etc. It will eventually add up to 0. This is the basic formula. So if you take all of your forces, now these forces have to be in the same plane. And what does that mean? Well, if we look at the plane here, and we have our y coordinates and our x coordinates, you cannot add, whoops, let me redraw that. You cannot add your normal force and a horizontal force that is force applied. You cannot add these two because they're not in the same plane. So you have to make sure that they are in the same plane when you are adding these forces together. Let me just erase this here. So let's take a look at an example. We have a mother pushing a baby carriage with a horizontal force of 600 newtons. So let's draw the free body diagram of the carriage. So mother is pushing 600 newtons with a horizontal force. It does say horizontal. The friction force felt by the carriage is 400 newtons. Now friction will go against movement, so it's going to go this way. And we want to know, is the carriage in a state of equilibrium? Now when we take a look at these forces, we have to take into consideration the directions. So while this one currently looks like it's positive, it's actually negative because it is pointing away. It is pointing in the negative direction. So when we take our forces, you're going to have 600. We're going to be subtracting 400 from this because it is the opposite direction. And we can find that this actually results in a positive 200 newtons force. This means that the carriage is not in equilibrium because this force, the resultant force, is not equal to 0. And that is equilibrium. Thank you for listening, and I will see you next time when we start talking about inclined planes.